So for example, we want to find the net ionic equation from combining solid lithium with a solution of barium nitrate. The first thing to notice is that when barium nitrate dissolves, nitrate is one of your soluble compounds, so this is going to give us barium 2+ ions and nitrate ions in water. And nitrate is going to be your spectator. So what we're really looking for is solid lithium, and I see that on my chart way down here at the bottom. So this is one of the half reactions that I'm going to be dealing with. And the other thing I'm looking for is barium 2+ ions, and I see those right up here. So this is the other half reaction that I'm going to be working with. Now notice how in the problem solid lithium is a reactant, but on the list here it's listed on the product side. So that means that this is the reaction that needs to be flipped or reversed, and this will be your losing electrons, which is your oxidation reaction. So we have barium 2+ plus 2 electrons yielding solid barium. And then our other reaction we're going to flip and give us lithium with a +1 charge. Nope, just solid lithium reacting to form lithium with a +1 charge and 1 electron. Now remember how net ionic equations never show your electrons? So in order to combine these two reactions, they have to have the same number of electrons. So in order to do that, I'm going to double this whole reaction here and say 2 lithium yields 2 lithium plus ions plus 2 electrons. Now we can add these two reactions together and we'll see barium 2+ plus 2 electrons plus 2 lithium metal atoms yields 2 neutral barium atoms plus 2 lithium positive ions and 2 electrons. And this is a little bit like canceling the spectator ions. We have electrons on both sides of the reaction, so we can cancel those out. And our final reaction is going to be barium 2+ plus 2 lithium metal atoms yields 1 neutral barium atom plus 2 lithium positively charged. So the lithium is donating its electrons to the barium. Barium becomes neutral and lithium becomes positively charged. For example number 2, we're looking at solid magnesium in a solution of iron nitrate. So again, in solution, this is going to be iron 3+, and the nitrate ions will be spectators. So looking at our list of potential half reactions, I see solid magnesium right here. So this is going to be one of the half reactions that we're dealing with. And the second one, I see iron 3+. Now iron 2+ is in the middle here, but that's not what we want. Iron 3+ occurs all the way up here. So that's the second half reaction that we're going to be combining. And solid magnesium needs to be on the reactant side, which means this one down here needs to be flipped or reversed. And so that's going to give us magnesium, just solid metal, is giving up its 2 electrons to form magnesium 2+ and 2 electrons. Now in this equation we have 2 electrons. In the other equation that we're going to be using we only have 1. So I'm going to go ahead and double the coefficients on everything in this equation here. And that gives us 2 Fe3+ ions plus 2 electrons, yielding 2 Fe2+ ions. Now if we combine all the reactants and all the products, we've got solid magnesium, 2 iron 3 ions, and 2 electrons, producing magnesium ions plus 2 electrons plus 2 iron 2 ions. And now the electrons cancel out as they should, and we're left with the overall net ionic equation of magnesium plus 2 iron, 3 plus, yielding magnesium 2 plus and 2 iron 2 plus. Now to double check everything, we should have equal charges and equal numbers of atoms on both sides. So we have 1 magnesium atom on the left, 1 magnesium on the right. That's good. We have 2 irons on the left, 2 irons on the right. And in terms of charges, on the left-hand side, 2 times 3 gives us positive 6. Here we have 2 plus 2 times 2 is another 4. 2 plus 4 is 6. So we have 6 plus on the right-hand side. Charges are balanced as they should be.